Hello children, this is your Kirti ma'am and welcome to my channel Kirti ma'am Chemistry. Today we are going to start a new chapter from organic haloalkanes and haloarenes. Haloalkanes and haloarenes is probably the first chapter for organic chemistry in grade 12 and a very important chapter. Now without wasting any time, let's get into the chapter. Okay. Now let us understand these two terms haloalkanes and haloarenes separately. Okay. Haloalkane, haloarenes. Okay. Now let me divide the word haloalkanes into two parts. Halogen plus alkane. Okay, so haloalkanes are the combination of halogen and alkane. Now, when I say halogens, you people are aware because you people are in grade 12. Halogens are your fluorine, chlorine, bromine, iodine. It is basically 17th group of your periodic table elements are called as halogens. And you know halogens are highly electronegative. They have very good high ionization potential. They have smaller size when compared to metals. All that you would have already studied in your grade level. Now, halogen plus alkane is your haloalkane. Now, if you try to understand this in terms of its general formula. Now, what is the general formula of alkane? CnH2n plus 2 is your normal alkane, and this is the general formula of normal alkane. Now, I will remove one hydrogen from this alkane and add one halogen. What am I doing? I am removing one hydrogen from alkane and adding a halogen, forming what? CnH2n plus 1. One hydrogen is removed, so here instead of plus 2, now it is plus 1. Instead of one hydrogen, what did I get now? I got an halogen. So what is the general formula of alkane? CnH2n plus 2. What will be the general formula of haloalkane, which I got by replacing one hydrogen with halogen? CnH2n plus 1 X. Okay, so this is your alkane and this is your haloalkane. Clear? Haloalkane. You can also call haloalkane as alkyl halide. Now this I have shown you people by taking the general formula. Now I will take a normal alkane compound and I will show you hydrocarbon C2H6. This is my alkane. I will remove one hydrogen from this and add one halogen. Then what this will become? Okay, now let us take this halogen as some halogen. Instead of writing just X, let me take it as Cl. So what do I get by replacing one hydrogen with Cl here? C2H5Cl. What do I get here? C2H5Cl. This is my ethane. So this I can call it as chloroethane. Okay, if you talk in terms of IUPAC naming, I call it as chloroethane. Now if I talk in terms of my common naming, I call it as ethyl chloride. Now how to write the IUPAC name of haloalkanes, how to write the IUPAC names of haloarenes, I will teach you in detail regarding the IUPAC nomenclature of these two categories. So you don't worry regarding that. We will do IUPAC nomenclature in very much detail. Okay, so this is about your haloalkanes. Haloalkanes are formed by removing or replacing one hydrogen from alkane with a halogen, forming your haloalkane, which I also commonly call it as alkyl halide. Now when we come to our haloarenes, let's divide haloarenes like we divided haloalkanes. Halogen plus arene. Okay. Now if you are getting wondered what is arene, arene is your benzene. Now arene is your benzene and halogen plus arene together, when I say haloarenes, we can also call them as aromatic hydrocarbons. Wherever benzene is involved, we can talk about aromaticity. So halogen plus arene together form your aromatic hydrocarbons. Now let us see how does this happen. I have my benzene C6H6. From benzene, one hydrogen is removed and it has been replaced by your halogen. Then you will get your halogen on the benzene ring. So this is my haloarene Okay, and very commonly we can call them as aryl anides. Okay, now you can get here, okay, if you see the examples here, you can put chlorine in place of X and get chlorobenzene. You can get fluorine in the place of X and get fluorobenzene. You can write bromine in the place of X and get fluorobenzene. Okay, like this it goes on. You can replace it with hydrogen, iodine and get iodobenzene. Okay, so this is your brief introduction of what exactly are haloalkanes and haloarenes. Haloalkanes are formed when you remove one hydrogen from alkanes and put a halogen. And how to put that halogen is not as simple as I have shown you. We have many chemical methods and chemical processes to conduct their preparation, that we will see further when we do methods of preparation. But for a simple understanding, one hydrogen has been replaced by one halogen. If it is an alkane, it is haloalkane, and if one hydrogen of benzene is replaced by a halogen, then it is a haloarene. So this is the basic simple understanding of what exactly are haloarenes and haloalkanes. Now, before we go to the methods of preparation of these two very important compounds of organic chemistry, first let us try to understand the classification of haloalkanes and haloarenes. How are they classified? Now, when I say classification of them, classification happens on basis of many criteria. Now, when we do the classification of them, we try to classify them on different bases. We try to classify them on CX bond hybridization of carbon involved there. We can classify them on the branching of them. Okay, we'll see what exactly and how exactly we are going to classify them. Okay, so let us do classification of haloalkanes and haloarenes. Now let us see the classification of haloalkanes and haloarenes. I told you people we have a basis for classification. The first basis of classification is the number of halogen atoms. Based on the number of halogen atoms, how are we going to classify haloalkanes and haloarenes? So first is here monohaloalkanes or monohaloarenes. Monohaloarenes. Now, when do I say that monohaloalkane or when do I say it is monohaloarene? Now, if it is CH3Cl, means from methane one hydrogen has been replaced by chlorine. So, if one hydrogen gets replaced by one halogen, then I call it as monohaloalkane. If one hydrogen from alkane is replaced by one halogen, then I call it as monohaloalkane. We can write CH3Br. Okay, I can write C2H5Br. One hydrogen from ethane has been replaced by one halogen. Or I can also say C7H8Br, means one hydrogen from propane has been replaced by Br. So basically what are monohaloalkanes? When one hydrogen from alkane has been replaced by one halogen, I call them as monohaloalkanes. Ultimately you can see only one halogen in the compound because only one hydrogen got replaced by halogen. In the same way, if I say monohaloarenes, okay, now only one hydrogen has been replaced by halogen. Only one hydrogen has been replaced by halogen, then I call them as monohaloarenes. This is very simple, a simple concept to understand. Now let us see dihaloalkanes and dihaloarenes. As the name suggests, you can understand what are dihaloalkanes or dihaloarenes. Okay, now dihaloalkanes, dihaloarenes are further classified into geminal and vicinal. That also we will see step by step. Now here I can take as the name indicates. Now from alkane, when two hydrogens are replaced by two halogens, then I call it as dihaloalkane. Now you can see here CH2Cl2, okay, CH2Br2. Okay, it is very much obvious now. Now two hydrogens have been replaced by two halogens. Now they are arranged in two ways. Now based on that, again they are classified into geminal and vicinal dihalides. That we will see when I classify it further. Okay, before that let us write what are dihaloarenes and then polyhaloalkanes or polyhaloarenes. Then I will classify dihaloalkanes further. Okay. Now, okay, here I will write here, when I talk about dihaloarenes, now when I replace two hydrogens with two halogens, when I replace two hydrogens with two halogens, I call it as dihaloarene. Okay, in mono only one hydrogen has been replaced by a halogen. In dihalo, two hydrogens have been replaced by two halogens. Now this these dihaloalkanes and dihaloarenes are further classified into geminal dihalides and vicinal dihalides. Now what are geminal dihalides, what are vicinal dihalides? We will see in detail by taking proper examples. Now what is the third category here? Okay, they are your polyhaloalkanes or polyhaloarenes. Okay, now the name makes it very obvious. When more than two hydrogens have been replaced by halogens, I call them polyhaloalkanes or polyhaloarenes. I'll take an alkane. Okay, in that if more than two hydrogens have been replaced by halogens, then I call them as polyhaloalkanes or polyhaloarenes. For example, you can take CHCl3, very famous compound, your chloroform, it is a polyhaloalkane. You can take CCl for your carbon tetrachloride. Okay, you can even take CHBr3, which is your bromoform. Okay, all these are very simple examples of your polyhaloalkanes. In the same way, you can take polyhaloarenes in which more than two hydrogens are replaced by your halogen. So I can write here X, 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 and this X can be any of your halogen. So this is the basic classification of haloalkanes and haloarenes on the basis of number of halogen atoms, monohalo, dihalo, polyhalo. As I already mentioned, we are going to further classify dihaloalkanes and dihaloarenes into geminal and vicinal. Now what exactly are geminal dihalides and what exactly are vicinal dihalides? Let us see in little more detail because it is very important when you go further in organic chemistry. Let us see it in little more detail. Let us further classify dihaloalkanes. Dihaloalkanes are further classified into geminal dihalides and vicinal dihalides. Geminal dihalides are also called as alkylidin halides. Vicinal dihalides are also called as alkyline dihalides. Now let us try to understand what are geminal dihalides and what are vicinal dihalides. For example, if I take a carbon, okay, a alkane, and from that alkane I replace two hydrogens and put two halogens. That is what is dihaloalkane. If I am replacing hydrogens from the same carbon, if I am replacing both the hydrogens from the same carbon and putting halogens, then I call it as geminal dihalide. Okay, I'll make it more simple for you. Let us take ethane. Let us take ethane. From this ethane, these two hydrogens are there on the same carbon. Okay, these two hydrogens are there on the same carbon. When hydrogens from the same carbon have been replaced by two halogens, then I call it as geminal dihalide. Now you can take an example and understand this. CH3, okay, CH3, CH, okay, Cl2. Okay, two hydrogens have been replaced by two halogens, that is my, okay, both the chlorine Cl2. Okay, if you want, I'll expand it and write down for your convenience. CH3. From this carbon, two hydrogens have been replaced by two halogens. So chlorine, chlorine, one hydrogen is there. Okay, so two hydrogens from single carbon, the same carbon, have been replaced by two halogens. Now, if you write the IUPAC name for this, what will be the IUPAC name? If you number first carbon, second carbon, either it is first carbon and second carbon, what will be the IUPAC name of this compound? 1,1-dichloroethane. What will be the IUPAC name? 1,1-dichloroethane. So IUPAC naming you people know, like you people have done a lot of examples in your grade 1, but what about the common name? If I try to write the common name, we will try to follow the format given here, alkylidin halide. So I have taken ethane here, so just write in terms of ethane. So what will be the name? Ethylidin. Okay, what will be the name? Ethylidin halide. Okay, ethylidin halide. Don't write dihalide again, it is just ethylidin halide. Clear with this? When you write ethylidene, it is understood that on a single carbon I have both the halogens. So this is about your geminal dihalides. Now let us go to vicinal dihalides. In vicinal dihalides, you have both your two hydrogens have been replaced by two halogens, but hydrogens from the adjacent carbon atoms have been replaced by your halogens. Okay, if you see here, hydrogens on the same carbon atom have been replaced by halogens. Here, hydrogens, I will draw here again your ethane so that there is no confusion here. Okay, what will I do? I will replace the hydrogens from the adjacent carbons with the halogens. Then which kind of dihalide will it will be? It will be your vicinal dihalide. You can take an example of some halogen and you can write down CH3. Okay, CH3. Okay, now on this carbon only I am replacing hydrogen and putting an halogen. So chlorine, carbon, chlorine, hydrogen, hydrogen. So from ethane, two hydrogens I have replaced with two chlorines on the adjacent carbon atoms. What will be the IUPAC name of this compound? 1,2-dichloroethane. Okay, this will be the IUPAC name of this particular compound. What will be the common name of that compound? See the format here to write the common name, alkylene dihalide. We are writing in terms of ethane. So how will I write it? As ethylene. I will write it as ethylene dihalide. Okay, here it is ethylene halide. Here it is your ethylene dihalide. So just you have to remember how to identify vicinal and geminal dihalides and how to name them. IUPAC naming is very easy as you have been doing it so much, but just remember the common naming pattern, so that is where you might get confused. Okay, so I have given you the format. Alkylidene halide is for geminal and alkylene dihalide will be for your vicinal. So this is the understanding about your geminal dihalides and vicinal dihalides. Okay, so we have classified haloalkanes and haloarenes on the basis of what? The number of halogens which are present in the compound and how many hydrogens have been replaced by how many halogens. On the basis of that, we have done monohaloalkanes or monohaloarenes, dihaloalkanes or dihaloarenes, polyhaloalkanes or polyhaloarenes. Okay, now our next classification will be on the basis of your very favorite hybridization. Hybridization of what? Hybridization of the carbon attached to the halogen. So now let us see the second type of classification of haloalkanes and haloarenes. Let's see. Now the second type of classification. Let us classify the compounds containing sp3 carbon bonded to halogen, that kind of bond. So basically we are trying to divide those compounds which have CX bond, carbon halogen bond, and in that CX bond the carbon has a hybridization of sp3. So in the CX bond, when it is a haloalkane and haloarene, you know there will be carbon halogen bond. Okay, that carbon halogen bond holding carbon should have sp3 hybridization. So on that basis, where the carbon holds sp3 hybridization, the haloalkanes and haloarenes have been classified into three types: alkyl halides, allyl halides and benzyl halides. Let us see them in detail. When you take alkyl halides, it is your CH3, CH2, Cl. Now when you take CH3, CH2, Cl, the hybridization. So what is the carbon halogen bond here for me? CCl bond. Okay, CCl bond. Now carbon attached to halogen is this carbon. Now if you check the hybridization of this carbon, now you people have studied the hybridization concept in your grade 11. I am not going into depth of hybridization. This carbon has 4 sigma bonds, so the steric number is 4. When the steric number is 4, the hybridization should be sp3. So this carbon's hybridization is your sp3. So alkyl halides have a carbon holding halogen, and that carbon has which kind of hybridization? sp3 hybridization. Now I can classify this alkyl halides further into three types: primary alkyl halides, secondary alkyl halides and tertiary alkyl halides. How will I write my primary alkyl halides? CH3, CH2, CH2, Cl. Okay, this is my primary alkyl halide. How can I say it is a primary alkyl halide? halogen is attached to that carbon which is in turn attached only to a single carbon. Now I can also write secondary. Okay, how will I write secondary alkyl halides? This is my secondary alkyl halide. How can I call it a secondary alkyl halide? The carbon holding halogen is further attached to two carbon atoms. Now let me write tertiary alkyl halide. The carbon holding halogen is further attached to three carbon atoms. Again, alkyl halides. Okay, alkyl halides fall under the category of sp3-CH bond. Why? Because here the carbon holding halogen is sp3 hybridized. Alkyl halides I can further classify into primary alkyl halides, secondary alkyl halides and tertiary alkyl halides. Primary alkyl halides, here the carbon holding the halogen is further attached to a single carbon atom. Secondary alkyl halides, the carbon attached to halogen is further attached to two carbon atoms. Carbon holding halogen is further attached to three carbon atoms. So this is about your alkyl halides. Now let me come to the allyl halides. Very important. Okay. If you take your allyl halides, here you have your carbon double bond carbon single bond carbon. Okay, this is the carbon skeleton and this carbon is attached to your halogen. Now you can fill your hydrogens CH2, CH, CH2, Cl. Okay, now allyl halides CH2 double bond CH, single bond CH2, Cl. Okay, so this is your skeleton for your allyl halide. Carbon double bond carbon, single bond carbon and this carbon is further attached to your halogen. So this is my CCl bond. This is my CCl bond. Okay, so this is my carbon halogen bond. Now I need to check the hybridization of this carbon. I need to check the hybridization of this carbon. If I check the hybridization of this carbon holds 4 sigma bonds. So steric number is 4. Whenever the steric number is 4, the hybridization is sp3. Here also this carbon is attached to 4. This carbon has 4 sigma bonds. So 4 sigma bonds, steric number was 4, so hybridization was sp3. Here also the steric number is 4, so the hybridization of this carbon will be sp3. Okay, this is one way. Now you can have the you can have allyl halides even in cyclic compounds. Okay, so this is my allyl halide. Okay, you can see the carbon skeleton here, carbon double bond carbon, single bond carbon and this carbon is attached to your halogen. So this is also an example of my allyl halide. And this carbon holds which hybridization? sp3 hybridization. So this is how you should be identifying allyl halide. First check for CCl bond. Okay, CCl bond is there. Now you will have a carbon attached to this carbon and this carbon should hold a double bond. So your basic carbon skeleton you need to identify in allyl halides is what? C double bond C, single bond C, single bond Cl. Now this is how you can identify your allyl halides. Don't get confused. Carbon double bond carbon, single bond carbon and this CCl bond is so there because it is a we are talking about haloalkanes. Okay, so these are your allyl halides. Now let me come to my benzyl halides. Now what do you mean by benzyl? What do you mean by benzyl? Okay, so this is my benzene ring. Okay, on this benzene ring, I have my CH2 group and to this CH2 group, I have an halogen attached. The halogen can be anything. I am just taking chlorine. I have just taken chlorine as an example here, but you can take any halogen, fluorine, chlorine, bromine, iodine. I just took one of the halogen. Now if you see here, okay, benzyl halide, this is my benzyl group. This is my benzyl group. Be very clear, you will not attach bromine onto the benzene ring. No. Benzyl group is, you have your benzene ring. On that benzene ring, you have CH2 group. To that CH2 group, I have a halogen attached. So this is my benzyl group and this type of halides, I call them as benzyl halides. You will see lot of benzyl halides in this chapter. So now I have to check the hybridization of this carbon because this is my CX bond. So I will check for the hybridization of this carbon. Now when I check this carbon's hybridization is what here? This carbon's hybridization is sp3 because this carbon holds 4 sigma bonds. So steric number is 4. So the hybridization will be sp3. Okay. So benzyl halides also come under the category of compounds containing carbon which has hybridization sp3, and which carbon we are talking about? The carbon holding the halogen. Okay, so what are the three categories of compounds which hold sp3? CH bond, alkyl halides, allyl halides, and benzyl halides. Now let us see the third category of classification, where we will see the compounds containing sp2CH bond. Hope sp3CH bond is clear for you. Okay, now we are going to see the compounds which have sp2CH bond. So let us see that now. Now the next category is compounds containing sp2 carbon bond halogen. Okay, now what does it mean? We have to check for carbon halogen bond where carbon is holding sp2 hybridization. So it is sp2 carbon halogen bond. So we have to check for the hybridization of carbon holding halogen whether it is sp2 or sp3. In the previous case, we found that the carbon was holding sp3 hybridization. Now here we will be seeing the carbon holding sp2 hybridization. Okay, now let us see here vinyl halides and aryl halides. These both type of halides, they have carbon containing sp2 hybridization. The carbon holding halogen has sp2 hybridization. Now when we try to understand vinyl halides, it is your CH2 double bond CHX. Now this is your carbon halogen bond. Now this carbon I have to check the hybridization of this carbon. Now when you check the hybridization of this carbon, it has one sigma bond here, second sigma bond here, and the third sigma bond with hydrogen. If you want, I will write this in detail once. Okay, so this carbon I have to check. This carbon has how many sigma bonds? 3 sigma bonds. When it is 3 sigma bonds, the steric number is how much? 3. When the steric number is 3, my hybridization will be sp2. So in vinyl halides, the carbon holding halogen will have a hybridization of sp2. Okay, now you can take any example: CH3, CH2, CH2, CH2 double bond CHX. Okay, do I call this as vinyl halide? Yes, I call it as vinyl halide because I will check for this. Okay, if I get a carbon skeleton like this, carbon double bond carbon single bond halogen. If I get a skeleton like this in my compound, I will call it as vinyl halide. Now in the previous classification when I was teaching, I taught you what? Carbon double bond carbon carbon halogen. I asked you to check for this skeleton over there, and I told you will call it as allyl halide. If the carbon skeleton is C double bond C, single bond C, and to this carbon halogen is attached, it is your allyl halide. It is your carbon double bond carbon to this double bonded carbon. If halogen is attached, it is vinyl halide. Here the halogen is attached to a carbon which has only single bonds. Here the halogen is attached to a carbon which is holding a double bond. This carbon is sp3 hybridized and this carbon is your sp2 hybridized. So please check in the question. Don't have any confusion in your mind regarding allyl halides and vinyl halides. Okay, in vinyl it is carbon double bond carbon to this carbon halogen is attached. In allyl it is carbon double bond carbon single bond carbon, and to this carbon your halogen is attached. In allyl the hybridization of carbon holding halogen is sp3. In vinyl the hybridization of carbon holding halogen is sp2. Now hope vinyl halides is clear to you people. Now let us go for the second type of compounds where you have sp2 carbon halogen bond. Okay, now aryl halides is very simple. I already told you what are aryl halides. You have your benzene ring. Okay, from the benzene ring, one hydrogen has been replaced by a halogen, and this halogen can be chlorine, bromine, iodine. Now, when you check here, this carbon, okay, if you want, I will write this in detail. The benzene structure, if you see. Okay, you have your alternate conjugate system in benzene, and you people know all the carbons hold hydrogens here. Okay, that is the reason the formula is C6H6. Now, if you take the hybridization of any carbon in benzene, any carbon, not only an individual, any carbon, okay, any carbon in benzene, the hybridization of that carbon will be sp2. Okay, because if you see this carbon, how many sigma bonds? 1, 2, 3 sigma bonds. So steric number 3, hybridization sp2. Take this carbon, how many sigma bonds does it hold? 1, 2, 3. 3 sigma bonds, steric number 3, as hybridization will be sp2. So when I am talking about this carbon, here the hydrogen has been removed and we have put what here? And we have put halogen. Now you check the hybridization here. How many sigma bonds does this aryl halide or haloarene hold? 1, 2, 3. So still the steric number is 3 because it is 3 sigma bonds. So the hybridization of this carbon here will be sp2. So in the aryl halides, the carbon holding halogen will have which hybridization? It will have your sp2 hybridization. So what are the compounds containing sp2-CH bond? They are your vinyl halides and your aryl halides. Okay, so we have in detail classified haloalkanes and haloarenes on the basis of the number of halogens they have and on the basis of hybridization of the carbon holding halogen. Okay, so this is the basic understanding of haloalkanes and haloarenes. What are they? Okay, and how are they basically classified? Okay, that is what I taught you today. Hope you understood the session. Hope you loved the session. Okay, in the next class, I am going to teach you in detail about the IUPAC nomenclature and isomerism of these compounds. So till then, keep learning chemistry, keep loving chemistry. I'll see you in the next class with the IUPAC nomenclature and isomerism. Till then, bye bye.